So, lesson 2.6 today, finding values from areas. We're going to let the applet do all of the work for us. And it's like, if you get a little lost, especially next week when we take our quiz, it's like, how did we do that on the applet, sir? I literally typed out the instructions for you of like how we did that. So this is a very valuable worksheet to have on test quiz day, which will be next Wednesday. We'll have like a review day on Monday, and then we'll do the quiz on Wednesday. So check it out. They keep bringing up this data about those vocab tests in Gary, Indiana. Here's the distribution. It's pretty normal, right, with a mean of this and a standard deviation of that. Let's go put that in the applet real quick, you know, a mean of 6.84 and standard deviation of 1.55. So we got that in the applet, plot the distribution. Let's see what they ask us to do today, though. They're asking us to, like, see what score, so just kind of helping you out when you are reading your homework questions or when you're taking the quiz and it's all mixed together. When they say, what score would a student have to earn to be at a 90th percentile? Well, remember, the average score on this test was this 6.84 with the standard deviation of this. Let's check out these instructions of how we figure it out. It says, if we go to the normal distributions applet and we type our stuff in, there's some drop-down menus that say, instead of calculate the area under the normal curve, it says calculate a value corresponding to an area. That's what we want today. We want the value. And since they want the 90th percentile, we'll use the left tail graph most of the time, and all we got to do is type in 0.90 or just plain old 0.9 if you wanted to, and it will calculate the value for us. And it shades everything to the left of that. That's like 90% of the students scored that, you know, like less than this guy. So it's right here with this value of 8.26. So I think the homework might have you round it to 2 decimal places instead of 3, just see what they say. But does yours do 2 or 3 decimal places on yours? It kind of depends on how you have your settings. So I'll do 8.26. Sorry, I keep going the wrong way. That's it, 8.26. Oh, but that's not, what was it, 8.83? Sorry, I looked at the wrong thing. Was it 8.83? Is that right? 8.26, that's what I was doing. 8.826, thank you. That's that guy. If you notice, this is going to come in handy anyway. It also gives us a z-score when we do that. It's like, that's kind of nice. So, but they wanted to know what value it was. If you go back to this dude right here, it's like, what score? The score of 8.26, you know, was the 90th percentile. So let's try another one of those. The average sale price for a certain brand of professional mountain bike is approximately normal with a mean of this guy and a standard deviation of that. Find the 30th percentile. So we'll go punch those numbers into the applet. It's got a mean of 4,200 and a standard deviation of $250. So they're buying a mountain bike. Plot the distribution. We still got to have it on the menu of a value corresponding to an area. So I've got that. They want the 30th percentile, so you just change this to 0.30, and it will do it for us. And that's $4,068.90. Because, you know, it's just kind of like, what's going on with that dude? Like, that, how much did the mountain bike cost? So $4,068.90. Just looking at the data, would you believe that is definitely less than the average price? You know, the mean is 4,200. It's the 30th percentile. So like 30% of the mountain bikes that they saw cost less than that. So, cool. There's two more of these. Local post office weighs outgoing mail and finds that first-class letters are approximately normal with a mean of 0.69 ounces and a standard deviation of 0.16. Find the 65th percentile. Why don't you pause the video and get that done through the applets. Find the 65th percentile. So with all that data in there, 0.69 and 0.16, finding the 65th percentile, we got 0.752 on that dude. So 0.752 ounces. Then see what's different about 4. Read that guy. See what's a little bit different about him. They say 1% of response times take at least this many minutes. This is kind of like a think backwards. if 1% take at least this many, that means you really want to find the 99th percentile. You know, it's just like, oh, 1% should do this, so that means you're at the 99th percentile. So same concept. You could enter the data, mean of 22, standard deviation of 6.9 minutes. And because they wanted like at least 1% to do that, we'll go with the 99th percentile and do this. The other way you could have done that, instead of thinking about the 99th percentile, is you could change it from a left tail to a right tail, but then you got to change it to the 1% like they just told you, and that will give you the same thing, you know. So it's the same concept. If at least take this much, then that means go to the right of it in that case. So pretty basic right there. Notice they were just asking you what the value was. When we go to the other thing that they ask us, they say to find like the standard deviation given a percentile. So they're going to give me the percentile. What we need is this formula. So you might even like circle or something like that. That's our z-score formula. We've used it before, but now it's on another worksheet. And this is kind of a little trickier of how to set things up. We're going to like totally cheat the system using the applet. It's a little trickier. So I want to read the questions just so you can understand what they look like on homework. The clinical growth chart at this website shows percentiles corresponding to different heights of children for each sex and age. For 7-year-old girls, the mean is 48 inches, and they give me this percentile. Right? You with me? With the 90th percentile is 51 inches. Assuming that the distribution of height for 7-year-old girls is approximately normal, find the standard deviation. Well, here's the instructions that I typed out for us. We are going to cheat, and we don't actually put in the real mean and this number, because this number is not the standard deviation. We're going to go to the applet, and we're going to let the mean be 0 and the standard deviation be 1. Because all that's saying then is like, okay, here's your mean. It's right at 0. This is 1 standard deviation above the mean, 2 standard deviations above the mean, 3, etc. All that good stuff. Let's see what the instructions say to do after that, right? So we put the mean of 0 and a standard deviation of 1 and plotted it. Use the given percentile. Select calculate boundary values for a left tail area. So let's go do that. We got to do a given percentile. So we're still on this drop-down menu before. We want to do left tail. I changed mine to right tail. And didn't they say, was it 90th percentile? That's what they gave me in the problem. So I'm going to do 90th percentile. And what it really tells us is the value, which is also the z-score, because we let the standard deviation be 1 or anything like that. So we are like cheating. We are going to steal the z-score from this guy. So let me go back to our worksheet here. I'm going to jot down that the z-score was 1.28. All right, we figured that out. That means you're like 1.28 standard deviations above the mean, because it's a positive z-score, because positive means you're above it. But what that really does for us is it allows us to use this formula to do just a small bit of algebra. Remember, this is your z-score. This is your z. This is just a certain value that you have right here. This is the mean, and this other dude right here, that weird symbol, is your standard deviation. So I'm going to sub in what I know. I know the z-score is 1.28. And then there's an equal sign after that. And then we got to go back up here and realize this x is the value of this 7-year-old girl. That's who's at the 90th percentile. You see that 51 inches is like the value of the 90th percentile. So I will put 51 up there. Take away, what's this mean? This weird symbol? That's the what? That's the mean, right? They should tell me the mean of 48, right? You okay with that? And that's over the standard deviation. If you want to put that little sigma, you're welcome to. If you want to call it SB because you don't like drawing that, you're welcome to. I don't care, you know, but it's the standard deviation. Cool. So let's do one small little bit of cleanup right here. Figure out what 51 minus 48 is upstairs in that fraction. What you got? 3. Are you okay with that? And here's the ugly thing that we get a little scared of. I don't like this standard deviation being downstairs. This is a divide by sigma. The way I can get that to go away is multiply both sides by sigma. So when I do that, you know, this would turn out to be 1.28 times that sigma, if I showed you the work, sorry guys. That'd be 1.28 times the sigma, and these would cancel each other out, and you're just left with a 3 over there. So like 1.28 sigma equals 3. And since these dogs right here are being multiplied together, guess how I can get rid of that times 1.28? How do you get rid of multiplication, y'all? We're going to divide. That'll be 3 over 1.28. And then I'll go to my calculator. Sorry, I don't have it open.